UFO theory linked to blast on the morning of June 30, 1908. The remote Siberian wilderness near the Podkamenaya Tunguska River experienced an event of unimaginable scale, a cataclysmic explosion estimated to be equivalent to 185 Hiroshima bombs, flattened an area of over 800 square miles. Trees were scorched and felled, reindeer were incinerated, and the sky glowed with an eerie, unnatural light for days. The sheer force of the blast was so immense that it registered on seismographs as far away as England. Yet, bafflingly, no impact crater was ever found. This absence of a crater, coupled with the strange atmospheric phenomena that followed, has fueled decades of speculation and outlandish theories, ranging from antimatter collisions to miniature black holes. But perhaps the most enduring, and certainly the most sensational, hypothesis involves extraterrestrial intervention. A theory that refuses to die, clinging to the mysteries of the Siberian taiga. The immediate aftermath of the Tunguska event was shrouded in mystery, primarily due to the remoteness of the location. Tsarist Russia was in turmoil, and the sparsely populated region was far from any major settlement. Eyewitness accounts from the Evenki people, nomadic reindeer herders, spoke of a fiery god descending from the sky, accompanied by deafening roars and intense heat. One witness recalled being thrown from his chair and feeling an unbearable burning sensation. These initial reports, though fragmented and often interpreted through the lens of indigenous belief, hinted at something far beyond a simple meteor strike. Scientists, hampered by limited resources and logistical challenges, were slow to mount a proper expedition. This delay allowed rumors and speculation to flourish, transforming the Tunguska event from a natural phenomenon into a legend. The first scientific expedition to Tunguska, led by Leonid Kulik, didn't reach the site until 1927, nearly 2 decades after the event. What Kulik and his team discovered only deepened the mystery. They found a vast area of scorched and fallen trees, all radiating outwards from a central point. The trees, strangely, remained standing upright at the epicenter, their branches stripped bare. This telegraph pole forest, as it became known, was unlike anything seen in the aftermath of known meteor impacts. Despite years of searching, Kulik found no evidence of a meteorite crater or any substantial fragments of space rock. The soil was strangely devoid of metallic remnants, and the area around the epicenter seemed sterilized. Kulik's initial hypothesis of a nickel-iron meteorite simply didn't fit the evidence. As scientific analysis progressed, inconsistencies continued to plague the conventional meteorite theory. The atmospheric anomalies observed after the event, unusually bright nights across Europe and Asia, suggested the presence of vast quantities of high-altitude dust. However, the amount of dust required to produce such a phenomenon far exceeded what would be expected from a typical meteorite airburst. Furthermore, the pattern of tree fall was remarkably uniform, suggesting a highly directional and focused force. This raised the possibility of an aerial explosion occurring some distance above the ground, rather than a direct impact. The lack of a crater, the unique tree fall pattern, and the atmospheric anomalies all pointed to something extraordinary, something that defied easy explanation. In the decades following Kulik's expeditions, a plethora of alternative theories emerged, fueled by scientific curiosity and popular imagination. One of the earliest and most intriguing was the idea that the Tunguska event was caused by a comet composed of ice and dust. According to this hypothesis, the comet disintegrated completely in the atmosphere, leaving no trace on the ground. While this theory addressed the lack of a crater, it failed to adequately explain the directional force of the explosion and the high levels of heat generated. Another contender was the possibility of a natural hydrogen bomb explosion in the atmosphere, a highly improbable but theoretically plausible scenario. However, none of these theories could fully account for all the observed phenomena. UFO theory began to gain traction in the mid-20th century, amidst a surge in public interest in unidentified flying objects and extraterrestrial life. In 1946, science fiction writer Alexander Kazantsev proposed that the Tunguska event was caused by a nuclear-powered alien spacecraft that crash-landed or exploded over Siberia. Kazantsev drew parallels between the devastation at Tunguska and the atomic bombing of Hiroshima, suggesting that the aliens were either attempting to warn humanity or were simply victims of a technological mishap. This theory, while largely dismissed by mainstream scientists, captured the public imagination and became a staple of UFO folklore. It offered a convenient explanation for the lack of a crater and the unusual characteristics of the explosion. Proponents of the UFO theory pointed to several pieces of circumstantial evidence to support their claims. They highlighted the eyewitness accounts of a cylindrical or disc-shaped object seen streaking across the sky prior to the explosion. Some even claimed to have found metallic fragments at the site that were unlike any known terrestrial material. These fragments, however, were never subjected to rigorous scientific analysis and remain shrouded in controversy. Another argument centered on the rapid growth rate of trees in the affected area following the event, which some attributed to radiation exposure from a nuclear explosion. However, this rapid growth could also be explained by the release of nutrients from the decaying vegetation caused by the blast. Despite the lack of concrete evidence, the UFO theory continued to evolve, incorporating elements of science fiction and conspiracy theories. Some proponents suggested that the alien spacecraft was carrying a highly advanced weapon or propulsion system that malfunctioned, causing the explosion. Others claimed that the Soviet government had secretly recovered the wreckage of the spacecraft and was concealing the truth from the world. These theories, while often fantastical, served to keep the Tunguska mystery alive and to fuel public interest in the possibility of extraterrestrial visitation. They provided a narrative that resonated with the public, increasingly fascinated by the unknown. However, a significant shift in the scientific understanding of the Tunguska event occurred in the late 20th and early 21st centuries. Thanks to advances in computer modeling and atmospheric physics, researchers began to simulate the atmospheric entry and breakup of large asteroids and comets, taking into account factors such as altitude, velocity, and angle of entry. These simulations revealed that a relatively small rocky asteroid, perhaps only 50 to 80 meters in diameter, could have caused the Tunguska event. The asteroid would have entered the atmosphere at a shallow angle, compressed the air in front of it, and exploded with tremendous force several kilometers above the ground. This airburst would have produced the observed tree fall pattern and atmospheric anomalies without leaving a crater. Further bolstering the asteroid airburst theory was the discovery of microdiamonds in soil samples taken from the Tunguska region. These tiny diamonds, formed under conditions of extreme pressure and temperature, are characteristic of meteorite impacts and explosions. Their presence provided strong evidence that the Tunguska event was indeed caused by a space rock, albeit one that disintegrated in the atmosphere. While the discovery of microdiamonds did not completely rule out other theories, it significantly strengthened the case for a natural explanation. It suggested that the Tunguska event was not an isolated anomaly, but rather a rare but predictable consequence of Earth's interaction with space debris. But even with the ascendance of the asteroid airburst theory, lingering questions and anomalies continued to haunt the investigation. Some scientists questioned whether the observed tree fall pattern was entirely consistent with an airburst from a single object. They proposed the possibility of a swarm of smaller asteroids or comets, which could have produced a more complex and irregular pattern of destruction. Others pointed to the lack of any definitive asteroid fragments, even microscopic ones, to definitively prove the airburst theory. And then there were the persistent eyewitness accounts of unusual aerial phenomena, which some interpreted as evidence of something more exotic than a simple space rock. One of the most intriguing challenges to the asteroid airburst theory came from Italian researchers in the early 2000s. They identified Lake Chico, a small, deep lake located about 8 kilometers from the calculated epicenter of the Tunguska event, as a potential impact crater. They argued that the lake's shape and location were inconsistent with its formation by natural processes, and that it might have been created by a fragment of the Tunguska object. Further investigations, including seismic surveys and sediment analysis, revealed an unusual cone-shaped structure at the bottom of the lake, which some interpreted as evidence of an impact. However, the Lake Chico impact crater theory has been met with skepticism from many scientists. Critics point out that the lake's age is uncertain, and that it may have existed long before the Tunguska event. They also argue that the cone-shaped structure at the bottom of the lake could have been formed by other geological processes, such as the slumping of sediment. Furthermore, the size of the lake is much smaller than what would be expected from an impact large enough to cause the Tunguska event. Despite these criticisms, the Lake Chico hypothesis remains a subject of ongoing debate and research. In the final analysis, the Tunguska event remains a complex and multifaceted mystery, a testament to the power of nature and the limitations of human understanding. While the asteroid airburst theory provides the most plausible explanation for the available evidence, it cannot fully account for all the observed phenomena. The lack of definitive asteroid fragments, the persistent eyewitness accounts of unusual aerial phenomena, and the ongoing debate over Lake Chico all serve as reminders that the Tunguska story is far from over. It's a story that blends scientific inquiry with cultural mythology, a reminder that even in the age of science, the unknown continues to captivate and intrigue us. The legacy of the Tunguska event extends far beyond the scientific community. It has become a cultural touchstone, a symbol of the unknown and the unexpected. It has inspired countless